In this video, we are going to solve two unique problems where we can apply the sum and difference formula of trigonometric functions. Let's try the first one now. So let's try to solve the question number 1. In question number 1, the information given to us is a and b are two different values of x where they satisfy an equation of 6 cos x plus 8 sin x is equal to 9, and the range of a and b are 0 to 2 pi. Using this information, we have to find sine of a plus b. Now let's see what this actually means. So when they say a and b are two different values which satisfy this equation, that means the a and b are the roots of the equation. That is the first important point we have to understand. And when an equation has two roots, that means it is a quadratic equation. Correct? Now we don't see any term here in this equation which has a power of 2 or an exponent of 2. So to change 6 cos x plus 8 sin x is equal to 9 to a quadratic equation, we can square them and then apply the trigonometric identities. So how can we do this? So let's start solving this. So we have 6 cos x plus 8 sin x is equal to 9. So let's move 8 sin x to the other side. So we have 6 cos x is equal to 9 minus 8 sin x. So we have, let's square both the sides. So we will have 36 cos square x is equal to 9 minus 8 sin x the whole square. Let's apply a minus b the whole square. So we would have on the right hand side, we would have 81 plus 64 sine square x minus 144 sine x. Now let's change cos square x to sine square x by applying the trigonometric identity, which is 1 minus sine square x. So 36 times 1 minus sine square x is equal to 81 plus 64 sine square x minus 144 sine x. So let's simplify this question. So we would have 36 minus 36, sorry about that, sine square x is equal to 81 plus 64 sine square x minus 144 sine x. So when we simplify this, so this will be minus 36 sine square. We move it to the other side, it will be 100 sine square x. Then we would have minus 144 sine x. Then 81 minus 36 is 45. This is equal to 0. So this is our first equation. So this is a quadratic equation now. Now let's see what the question is. So the question is to find sine of a plus b. So what is the formula of sine of a plus b? We have sine of a plus b is equal to sine a cos b plus cos a sin b. But we don't know what sin a individually is or cos b individually is. We don't know that. So instead of finding them individually, what we can do is we can apply this trigonometric identity, which is cos square a plus b plus sine square of a plus b is equal to 1. So sine of a plus b is equal to square root of 1 minus cos square of a plus b. Correct? Now what is cos of a plus b? What is the formula of that? That is cos a cos b minus sin a sin b. Okay, now I just said that we individually don't know what cos a cos b is, sin a sin b. We don't know the value of these terms, correct? But is there a way we can find the value of these two together, which is product of cos a cos b and product of sin a sin b? Now let's go back to the quadratic equation. So what does a quadratic equation say? It is of the format ax square plus bx plus c is equal to 0. Now is this actually of that format? Here a is 100, b is minus 144 and c is 45. When it is of format ax square plus bx plus c, there is a concept called product of roots, and that is equal to c by a, correct? In this case, if we apply, if sin a and sin b are the roots, then sin a multiplied by sin b is equal to c by a, which is 45 by 100. So we know what is sin a multiplied by sin b. We individually need not know what the value of sin a and sin b is to apply in this equation. Now only thing pending is finding the product of cos a and cos b. So now what we can do is, if you notice here, we replaced cos square x with 1 minus sin square x. Instead of that, if we replace sin square x with 1 minus cos square x, we will get two roots again, which are cos a and cos b. So now what you're going to do is, we are going to rearrange the question so that we can have a quadratic equation with cos a and cos b as the roots. So 6 cos x plus 8 sin x is equal to 9. So let's write that down here. 6 cos x plus 8 sin x is equal to 9. Now what we'll do is, we will have 8 sin x is equal to 9 minus 6 cos x. Let's square both the sides. We will have 64 sin square x is equal to, let's apply the a minus b whole square formula. So we will have 81 plus 36 cos square x, correct, minus 144 cos x. Now let's replace sin square x with 1 minus cos square x. That would be 64 minus 64 cos square x is equal to 81 plus 36 cos square x minus 144 cos x. Let's simplify this. We will have 36 cos square x plus 64 cos square x, that is 100 cos square x minus 144 cos x, then 81 minus 64 we would have plus 17 is equal to 0. Now a and b are the values of x, that means roots of this equation are cos a and cos b, because a and b are the values of x that is given in the question. So product of roots is equal to cos a multiplied by cos b, which is c by a, and that is equal to 17 by 100. Correct? We have cos a times cos b is equal to 17 by 100. Now let's go back to the question. We have sine A multiplied by sine B is 45 by 100 and cos A multiplied by cos B is 17 by 100. Now we have to apply that in cos of A plus B formula, which is CosA.CosB minus Sine A Sine B. So we are going to write that down. It is going to be 17 by 100. So cos of A plus B is going to be CosA.CosB, which is 17 by 100 minus Sine A Sine B. So this is going to be 45 by 100, and when we simplify this, this will be minus 28 by 100, which is equal to minus 7 by 25. So now we know cos of A plus B. Let's go back to what we understood earlier. So we are going to apply this. Sine of A plus B is equal to square root of 1 minus cos square A plus B. This is a trigonometric identity we were using. Sine square A plus cos square A is equal to 1. So sine of A plus B is equal to square root of 1 minus 7 by 25 the whole square. So this is going to be square root of 1 minus 49 by 625. Now this will simplify to square root of 576 by 625. So square root of 576 is 24. And square root of 625 is 25. So sine of A plus B is equal to 24 by 25. So this is one of the unique questions we have solved in this playlist, where we have applied the concept of product of roots, which is C by A for a quadratic equation. And using this concept, we arrived at the value of sine of A plus B. Please watch this question, the solution again. If you have not followed, please drop a comment and I'll explain further. So let's try the second question now. So in the second question, the information we have is sine A plus sine B is equal to x and cos A plus cos B is equal to y. So we have to prove that sine of A plus B is equal to 2xy divided by x square plus y square, and cos of A plus B is equal to y square minus x square by y square plus x square. So we have the values of x and y. So we need x square and y square, x square plus y square and x square, y square minus x square for this equation. So let's find that out individually. So let's find out what x square plus y square is. So x square plus y square is sine A plus sine B the whole square plus cos A plus cos B the whole square. Let's solve the equation. It is sine square A plus sine square B plus 2 sine A sine B plus cos square A plus cos square B plus 2 cos A cos B. Now sine square A plus cos square A and sine square B plus cos square B, these are identities. So we'll have 1 plus 1. So we'll have 2 plus 2 times cos A cos B plus sine A sine B. This is cos of A minus B. So we will have 2 plus 2 times cos of A minus B. So this is the value of x square plus y square. Now let's try to find the value of y square minus x square. What would that be? Y square minus x square is sine A plus sine B the whole square minus, y square minus x square. So this will be cos A plus cos B the whole square, that would be y square, right? Minus sine A plus sine B the whole square. So let's start solving this. This will be cos square A plus cos square B plus 2 times cos A cos B minus sine square A plus sine square B plus 2 times Sine A Sin B. Okay, now we will have cos square A minus sin square B as one group here, plus cos square B minus sin square A as the other group, plus 2 times CosA.CosB minus SinA.SinB. Now, in the previous videos, we have learned that cos square A minus sin square B is cos of A plus B multiplied by cos of A minus B, correct? And similarly, cos square B minus sin square A again is cos of A plus B multiplied by cos of A minus B. That is a formula we added in the sheet in the previous video, and this is nothing but cos of A plus B. So this will be 2 times cos of A plus B. So this will be, we can add these two, first two terms, 2 times cos of A plus B cos of A minus B plus 2 times cos of A plus B. So basically y square minus x square is equal to 2 times cos of A plus B common 1 plus cos of A minus B. Okay, now in the question we have to find y square minus x square divided by y square plus x square. So let's divide this. So this is y square minus x square, correct? So y square minus x square divided by y square plus x square. So we would have 2 times cos of A plus B multiplied by 1 plus cos of A minus B divided by, what is y square plus x square? It is 2 times 1 plus cos of A plus B, correct? Because we have taken 2 as common between these two terms. Oh, I mean, sorry, this is A minus B. Now if you notice, we can cancel these terms, which is 1 plus cos of A minus B, and 2 also gets cancelled. So y square minus x square divided by y square plus x square is cos of A plus B. So now we know the first part. Now, when we know cos of A plus B, what is the other question we have? We have to find sine of A plus B, correct? So let's use the trigonometric identity. Cos square of A plus B is equal to 1 minus sine square of A plus B. So we can write sine square of A plus B is equal to 1 minus cos square of A plus B, and sine of A plus B is nothing but square root of 1 minus, let's apply the square of this cos of A plus B. It would be y square plus y square minus x square divided by y square plus x square, the whole square. Now it is just solving this quadratic equation, nothing more than that. So this would be, let's solve it. So we would have y square plus x square, the whole square, minus y square minus x square, the whole square, divided by y square plus x square, the whole square. So if we apply the equation, now it will have y to the power of 4 plus x to the power of 4 plus 2x square y square and minus y to the power of 4 plus x to the power of 4 minus 2 times x square y square divided by y square plus x square, the whole square. So here y to the power of 4 would get cancelled, x to the power of 4 would get cancelled, and this would be square root of 4 times x square y square divided by y square plus x square, the whole square. Sine of A plus B is this. Now if you resolve the square root, we would get sine of A plus B is equal to 2 times xy divided by y square plus x square. So this is how we can solve question number 2 just by applying few rules of algebra and also understanding how we can apply the sum and difference formula of cosine function, which is cos of a plus b and cos of a minus b. So I would recommend that you watch this video again to understand how we can apply the concepts, and please do try these 2 questions yourself, because it will give you a lot of applications of different concepts, and share it with your friends. Thank you so much for watching. I'll see you in the next video.